Today we're going to explore the area and perimeter of a parallelogram using Geometry Sketchpad. So let's start exploring. Here we have a line segment labeled XY, and as we select point X, we can adjust the length of XY. Now notice in the software, the length of XY is linked to the perimeter of the parallelogram. So as we adjust the length of XY, we're also adjusting the perimeter and the area of the parallelogram. So if we explore with that, we can see that the area is increasing at a certain rate and the perimeter is increasing at a certain rate. So one of the questions we can consider is, are the area and perimeter increasing at the same rate, or are they increasing at different rates? Okay, the next thing we want to explore is what happens when we deselect the line segment and now select point D. When we move point D around, we notice that only one calculation is changing, and the calculation that's changing is the area. The perimeter is staying the same. So how can we maximize the area of a parallelogram with the same amount of length in perimeter? And notice the closer we get to line segment AB, the smaller our area gets. And as we start getting farther and farther away, we reach a point at which we have the greatest area. 7.54 would be the greatest area, and that is because we form a right angle. What does that tell you about maximizing area in terms of what kind of quadrilateral would maximize the area? Okay, so now we're going to see what happens when we choose point B. Now what we're doing with point B is we're still keeping the perimeter the same, but we are changing the lengths of the line segments. It's still a parallelogram, notice, but we want again to maximize the area, and in order to maximize the area, well, the closer we're going to get AB to DC, the smaller our area is going to become. But as we reach a point, let's see where it's going to happen. Looks like it's 6.85, and then we start going down again, and 6.85, and then we start going down again. So that's right there, that's going to be our maximized area. And notice what kind of shape we have constructed. Line segment AB appears to be equivalent to BC, and BC equivalent to CD. So this appears to be a rhombus, which is the shape that would maximize our area. And now if we combine the fact that a rectangle maximized our area and a rhombus maximized our area, what other shape do you think would maximize the area by being both right angles and equilateral? A question to consider as we continue working on our Geometry Sketchpad files, area and perimeter of a parallelogram. And we'll see you next time.